We are live. Let's see. Yep. Test. Okay, works on Twitter. Okay, we have 8 viewers already. We're gonna wait for 1 more minute and then we're gonna start this live stream.
How to share.
We are also live on our Genlayer YouTube. Amazing. Okay, amazing. Everyone can hear me loud and clear, can see me loud and clear.
Yes.
Perfect. Yeah. Welcome everyone to our first X live stream. We are as nervous as you for the tech to function, for everything to work. I'm super happy to introduce you today to this space, which is called the Intelligent Oracle, Revolutionizing Insurance on the Blockchain. My name is Tony. I work for Jaeger AI. I'm the head of content. Jaeger AI is the development company behind Genlayer, and with me today are Edgar Snemsche, our CPO and co-founder of Jaeger AI, therefore Genlayer, Albert, our CEO and co-founder of Jaeger AI and Genlayer, and Christoph Mussenbrock, who is the co-founder of Etherisk.
Hi.
Welcome everyone.
Thanks, Tony.
As you've heard today, three people actually from Jaeger AI / Genlayer. Christoph, you have to represent Etherisc on your own, but whom better than the co-founder, right? So you're deeply involved in the project. Etherisc wants to make insurance fair and accessible. This is a decentralized protocol. And especially with Genlayer, we're going to talk about the use case of a parametric insurance. And you guys are going to tell us later on what a parametric insurance is and how you're utilizing Genlayer. Genlayer, on the other hand, is the first intelligent blockchain enabling AI-powered smart contracts. We're integrating LLMs deep, or actually on the ground layer of our consensus mechanism. And yeah, we've released a couple of products last week. We've released our studio with which developers can code. And we have also code our first intelligent contracts, actually, which will then also be usable in DevNet. And we also released the Intelligent Oracle, which we are going to discuss today, and also look at this one example with our partner, Etherisc, on parametric insurance and how parametric insurance and the Intelligent Oracle work together. Okay, that being said, I would like to give the floor to Albert and Edgars, because you guys are the ones that can share Genlayer's perspective of why do we need Genlayer, why is Genlayer there, and kind of transitioning from why do we need Genlayer, what is it made for, to what is the Intelligent Oracle and why do we need the Intelligent Oracle for. Right. Anyone who wants to start, Albert or Edgars, feel free to.
Yeah, maybe I'll kick it off with a bit of a Genlayer overview, and then Edgars, maybe you can dive on the Intelligent Oracle side, right? So we've been working on Genlayer for over a year now. The original idea was, look, why can't blockchains connect to the internet? Why can't blockchains do anything else aside from code, right? the idea here is like, there's tons and tons of DeFi protocols, there's tons of different blockchains, but ultimately, like, most of these blockchains have the same type of features. The question is, what could you do if you had blockchains that could natively connect to the internet? They could natively understand natural language. And so we've built this new type of blockchain, we call it an intelligent blockchain, that uses AI at the consensus level to essentially enable smart contracts that can natively connect to the internet and understand natural language, make subjective decisions, essentially trying to remove either the oracles, which are very limited in what they can do, or the humans that are, like in stuff like DAOs, for example, which are very costly and very slow, right? We're basically trying to bring in a new generation of contracts that are, the best of both worlds, between like traditional contracts and smart contracts, in a way that is really ready for the AI age, right? What we're building here is essentially a synthetic jurisdiction for AI commerce, and that will mean that AIs and humans are going to be able to make deals between themselves, having a trustless third party that will be smarter as them, in order to have a trusted system, right? A trustless system, actually. That's the super high level view. When I go into the Oracle.
Yeah, that's perfect. Tony, if you want to pull up my screen as well.
Yep. So right now I have Christoph on the stage. I think, Edgars, you have to share your screen.
I am sharing my screen.
Okay, let me see. Add to stage. That's Etherisc. Give me a second. I can't currently see your screen. Oops. That was. I just kicked out Christoph.
Did you kick him?
Yeah, I just kicked out Christoph.
Like it's our show now.
Yeah. Not everyone knows you're really live, because something like that can only happen on live, right? Exactly. Okay, we have to wait for a minute. Edgars, now I can share.
Oh, there you have it. There you have it. Yeah. Okay. Thanks, Tony. It's not like this is a critical thing, but it's nice to have on there. So as Albert was saying, GenLayer is the first intelligent blockchain, and under the hood, as he was saying, it integrates these large language models directly into the consensus mechanism. And the way it does that, I think it's, we don't have to go super deep into this, but I think it's valuable to understand, is that we have this consensus mechanism that we call the optimistic democracy. Basically, we have many validators with many different large language models, and they work together through this consensus mechanism to come to a conclusion about non-deterministic instructions, such as going out to the internet to fetch data or executing natural language instructions. Basically, we combine the intelligence of many different large language models, giving you kind of state-of-the-art accuracy. We like to talk about this mathematical theorem, the jury theorem, which says that, if you have some individual jurors that are, let's say, 80% accurate, as you start to combine more and more of them, you can really hit the 100% accuracy. So this is a way to take the accuracy of LLMs from 90%, depends on the task, all the way up to 100%, so that you can really have contracts with natural language, with code, with internet access that execute 100% reliably. It's just a kind of super high-level diagram showing you there's a leader, and then some validators are checking what the leader has done and voting on it, and there's a multi-stage process for them to arrive at finality. Yeah. That's how it kind of works under the hood.
Yeah, I just made it a bit bigger so everyone can see.
Yeah, thanks, Tony.
Thank you, Edgars.
And then more at the high kind of architecture level. So what we're proposing here is basically with Etherisc or any other prediction market or all kinds of different use cases. They can use GenLayer from whatever platform they are on. So through inter-blockchain communication protocols, you can have these contracts that live on GenLayer and resolved super accurately. But then basically through inter-blockchain communication protocols, you can kind of like a universal oracle. You can live on Ethereum, you can live on Solana, you can live on Base, wherever you exist, and have GenLayer resolve these markets for you. Yeah. And basically this is addressing the limitations. So let's set the stage a little bit. So what's happening right now is that if you're on a blockchain, if you've built it at all or used it, you kind of know, maybe you take this for granted, is that these contracts, they're isolated from the outside world. What does that mean? It means that you either have oracles, kind of like Chainlink, different kinds of automated oracles. The problem with these oracles is that they only work for very narrow types of data feeds. They only bring you, some price feeds, maybe super basic weather data. But the problem with that is you kind of need very well-defined, exactly the same type of data source, data feed. Kind of setting up a new oracle is very slow, very expensive. For most use cases, it's just not going to happen. The alternative is, if you want to resolve something that's a more advanced question, you typically have used humans so far. So you build this kind of organization of people that can propose an answer, check an answer. This is something like UMA or Claros or different human-based oracles. The problem with these systems, they can answer any question, so they're not limited the same way as oracles are, but they are super slow, super expensive. Just kind of humans naturally, let's say they need to sleep, they need to eat, they need to wake up, before they can even make a decision. So naturally, it's going to take multiple days. That's the kind of time scale you're talking about. And then, you think about human salaries and then kind of everything like that. It adds up, meaning you cannot actually do many use cases economically. You need large scale for many of these use cases, markets or insurances, to make a lot of sense. And GenLayer kind of sits in the middle of that, where you can have these bespoke questions, any answer that's on the internet that can be found, that can be extracted, even in kind of natural language, news articles, anything like that. GenLayer can use large language models to resolve these kind of questions by going out to the internet, fetching the data, and then doing this consensus among many different validators with many different large language models to really super reliably extract this answer, and then through this architecture, pass it on to any protocol on any blockchain and act as the resolution mechanism.
Cool, perfect, Edgars. Thank you very much. If you could just also stop your screen share so I don't have to kick out Christoph again, that would be amazing. Thank you. Okay, sorry, Christoph, for that. Yeah, maybe you can share some of Etherisc's perspective. Like, what do you guys aim to do? And from there on, we will also, talk about how the intelligent oracle fits into this. So, what do you guys do at Etherisk, and what is your vision and mission?
Yeah, I think today I talk mainly to the GenLayer audience. I think the Etherisc people who are watching have heard this 100 times, so it's a bit boring maybe. But let me do the in a nutshell pitch. So Etherisc is a decentralized insurance protocol. We built a base layer for the future of insurance on blockchain. So insurance is a complicated process with many components. You have distribution, you have claims management, you need underwriting, risk management. So insurance itself is a very complex business. And our vision from the start was that we can put all of these parts on blockchain and use blockchain to bring more transparency, fairness, accessibility, and of course also efficiency. And oracles play a crucial part in the whole journey. So insurance needs information about risks, information about losses, damages, catastrophes, all types of things what can happen. Usually these are the bad things which happen, and we need reliable information because that's also a lot of possible fraud. People, insurance companies collect a lot of money, and other bad actors want to extract this money by permitting fraud. So this is all very complex machinery. And we have built this, we always say this is something like an operating system for insurance on blockchain. So a base layer which has all these components which do the heavy lifting, and people with business ideas for insurance or product ideas can then very simply and very easily and with a very short time to market build their own insurance products. So we are not an insurance company, but we enable insurance companies, but also we enable future players on the market which may or may not be insurance companies, but which deal with risk or insurance-like products. And we enable these players to bring their products to the market very quickly on blockchain with a very high level of efficiency and also security, of course. So this is the general setting, and what we are doing concretely.
So maybe, sorry to interrupt you, Christoph. So we could say, as January is for dApps, right? We are kind of the infrastructure for dApps. You are the infrastructure, the core for insurances to be built on.
Yeah, it's like an operating system like iOS or Android for insurance. Yeah. So everybody can build their own app with a very simple, like the Lego blocks. Yeah, you can put your product together, and typically a typical product on the Etherisc GIF, which is the name of our framework. A typical product has, let's say, 700 lines of code, which is absolutely minimum. In the background, there is a large machinery of smart contracts which work together and do all this processing and keeping track of everything. Every object is an NFT. You can trade policies. So it's a very generic system, and everybody can choose what he wants to do with it. And we have some examples. We have both so-called showcase products, which we use to demonstrate the technology, but we have also live applications with large-scale implementations, especially in the emerging countries. We serve insurance for smaller farmers in Kenya, in Bangladesh, in Mozambique in the future. And so these are examples how we can use this technology to serve insurance for uninsured people who have no access to financial infrastructure, and our solution makes it possible. And yeah, this is pretty complex. And the other applications, let me continue with the other examples. We are not limited to developing countries. We also have crypto-native solutions, for example, a DPEG insurance. You have, for example, USDC. And if you have watched the development of USDC over, for example, the FTX collapse, then there has been a so-called DPEG event. USDC went down to 0.8 US dollar. It recovered again, but people who in panic sold their USDC, they lost money. And with our solution, we have an automated solution which tracks the price of USDC. And as soon as USDC depegs from the $1, then we trigger an automated payout. And this is a solution where people can also be on the other side. So you can also invest in such an insurance product, because the people who buy the policies pay a premium, and the premium is then distributed to the investors who provide the risk capital. So we also cover both sides of the game, both the customer perspective and also the investor perspective. And but in many instances, we rely on third-party solutions. For example, we do not implement our own asset management. We do not implement our own payment system. We do not implement oracles. And that's where you come in, because we always had the need for good oracles. But we also were pretty sure from the beginning that creating good oracles is a very complex project of its own. And we should focus on the process, insurance, and creating good Oracle solutions is a very specific task. And so I'm very happy that we are now collaborating here, and because Genlayer is also adding a very specific new kind of Oracle, which is very useful for insurance, and maybe we can go deeper in this topic later on.
Yeah. Definitely. No, we like if you can share how the workflow for you, if you break it down, you know, we've seen this image that we had for the intelligent oracle with the prediction market. If you break it down, like which part of the workflow is being automated using Genlayer, or what part of this workflow actually is falls through because you implement our intelligent oracle.
Yeah, let me just share my screen.
Sure.
So I can show you our. I think you need to share it now. Exactly.
So this is this your screen? Yes.
No, this is not mine. I just
because
shared.
If I kick, I don't want to kick Edgar's again. Okay, let me. Oh, now I have you. Now I have you. Here you are.
Okay, so this is
Okay.
the very generic process how basically any insurance works. Yeah, so we start collecting metadata, name, address, phone number, whatever you need from a customer. This is a metadata. We start a process, and then it starts with a so-called application. Yeah, you all know the paper form which you fill in when you talk to an insurance agent. Of course, in our case, this is not on paper, but it's a data object on blockchain. So we start this application, we collect the necessary data for the product. This is very specific on dependent on the product. And then we make a decision either to decline the application because some parameters don't fit into the requirements, or we go the second step, go to underwriting. And there we have all these black bubbles here, and numbered 1, 2, 3. And these are all decision points, yeah, where we make a decision. Either, for example, if a customer enters this data, then the first decision, do we want to work with this customer? Is he in the right region, in the right country, right age, right sex, and whatever? And then this is the first decision. This could be done by an oracle, but it can also be hard-coded in the code, in the smart contract. The second thing is, do we accept an application? This is we check the risk. Is the risk also fit? Does it fit into the requirements? For example, if you have a fire insurance, is it in the right place, the right type of building, and whatever? Is it in a high-risk region, whatever? And then you make the second decision, number 2. And this could also already be where we start the first oracle call. Yeah, so we ask the oracle, we provide the oracle with the risk data, and the oracle will give us a feedback. First, is this risk acceptable? Do we want to underwrite this? And secondly, at what price? So what is the quote for this policy? If this is a positive answer from the oracle, then we underwrite the policy, and we now have a legal valid contract documented on blockchain. And this will now yield a so-called active policy. So this policy is now able to accept risks. And now we watch over a certain period of time, either limited for a year, a season, or even unlimited. In case of a life insurance, we watch the risk, and we try to figure out, is there any claim? The claim can either be filed by a customer actively, or it can again be triggered by an oracle. This is number 4 here. The black bubble with the 4 is where we call the oracle. The oracle can either be called proactively by ourselves. For example, we have this flight delay, where we have the scheduled date of landing, and then we know, okay, at a certain period of time, we need to check the oracle. Is the plane landed, or does it have a delay? Mm-hmm. Or in case of crop insurance, at the end of the season, we check, has there been enough rainfall, or has there been a flood or other catastrophic event? So this is where we call the oracle. But of course, the customer could also trigger the oracle and say, okay, I have noticed a damage, but of course I cannot report the damage myself because that would open every door for fraud. But now we need an expert, and the oracle is nothing else like an expert who answers what is the damage, and how much damage, what is the payout or the claim amount in dollars or in the currency which policy is denoted. And then we create a claim. The claim can then either be declined if a closer check will say this claim is not justified or does not fit into the terms and conditions, or it is confirmed, and then we start a so-called payout. The payout is the last step. There is typically also a last check by the financial department, because maybe liquidity needs to be provided. So this is a separate step, even if there is no fundamental decision being made. But at least somebody needs to say, okay, I have the money on the account, can that now be transferred to the customer? So this is the fundamental process. And as you see, there are at least 2 critical points. The first point is the underwriting. Oracle, and the second is the claims Oracle. Yeah, so these are the typical oracles which we use. The other things can typically be hard coded. We don't need an Oracle call to the outside, but 2 and 4 are typically the Oracle calls. And
Christoph, sorry to interrupt you. Could you give us, like, before we go into the technical explanation by Edgars and Albert, could you give us like an example or two of what event would that be?
Let's look into crop insurance, because it's a pretty simple example. Crop insurance has 2 stages. The first stage is the development of the product itself, which is done by an actuarial expert. So he takes typically a history of the weather data, makes an actuarial analysis together with the plant model. So we have a theoretical model, how much water and wind and sunlight the plant needs. And from all of this, we create a pricing table. So the pricing table will just say, if there is a plant in a certain region at a certain time planted, then the farmer needs to pay such and such to insure against certain perils. Then we have the seasonal execution, which is on blockchain. So in the first step, we have this, what we have seen before, the process with activation and application and underwriting. This is happening in the first stage. And then we have real-time weather data. And now here is a place where the claims Oracle comes in, and where we check weather data and decide if there is a claim. Typically at the end of the season, but it can also be in real time, mid-season. And this is can be a simple process. For example, the weather satellite says there has been no rain for 7 weeks, so it's complete drought. The plant is damaged or completely dried, and we can trigger an immediate payout. But there are also more complex situations where we have, for example, intermittent rain, and so we need to make an analysis. This can either be done by an algorithm, but it could also be done by an AI solution here.
Christoph, let's look at thank you for this example. That's wonderful for everyone to understand how it really can be used. Let's look at the parametric insurance for flooding a bit later. Maybe we can go into the technical integration of all of this, right? Like some people may wonder, okay, you have this solution here, which everyone can use. Insurance is decentralized. You don't need humans in the loop. It's automated. It works fast. Like, I mean, everyone, for me, I'm living in Germany, and I think every one of you guys in Europe, at least, right? Like everyone knows how lengthy this process can be, filling out this form, like, I think insurance is, after banking, is one of the most regulated sectors. So I think it's amazing that we have this one example. But, also for the businesses and for the people watching here, like, how does the technical integration look? And
let's just watch a simple live example.
Tony, so Christoph, one thing that I think it's interesting is like the oracle bit, right? Like in this situation, right? Like how do you find those oracles? Like what type of limitations do they have? Like what issues are you having right now with the oracles?
Yeah, the oracles what we have typically are just pipelines for pre-processed data. Yeah. So, for example, let's go back to the parametric case here. We have the weather satellite. The weather satellite actually delivers just a big table of data every day or every hour or whatever. And so the role of the oracle, for example, what we currently use is just pipeline this data to the blockchain. Yeah, so it reads from the weather satellite and then it puts it on blockchain. We can process it and make some actions, but there is no intelligence involved here. Yeah, so it's just plain data. And the same for what we have in the second example, the flight delay. This is our flight delay protection. You select an airline and let's say here, just one flight as an example. So it gets a bit more tangible. So we have this,
I'll make it a bit bigger.
slide. Yep. Is it
Just
okay?
so everyone can see it. Here we go. Yeah.
Okay, so we have now this flight. It departs on the 8th of December. You can, of course, also select other dates here, but let's take this one. And this is a very punctual flight. Yeah, so it's on time in 60% of all cases. And so you get the maximum payout of $200. This is defined. If this flight would not be so punctual in history, so we use historical data here, for example, only 50% punctual, then you would get a lower payout. And then you can buy it. You click on buy, and then I have not enough on my wallet here, so I would need to switch my wallet, which I currently have no wallet with enough money in it. But let's just take it for granted. You buy the policy, and then the process starts. And on the 8th of December, when the flight lands, then we check the Oracle, and the Oracle is just doing an API call to the database, the flight database, which is maintained by a company which collects flight data, and then depending on the outcome, we make it a payout or not. So this is very straightforward, and there is no intelligence. We just the Oracle just forwards the data. But many insurance use cases cannot be handled like this, because you need more intelligence. Yeah, for example, let's say you have a household insurance. Yeah, you have a TV, and the TV is broken for some reason, because of you have an electrical defect or whatever reason, and now you file a claim. Now you need to detect if this claim is justified. Yeah, there is no database which you just can ask. You need intelligence. Yeah, you need, for example, a dialogue with the customer and ask the customer questions. Yeah, what is the value of the TV, and how was the event? How did it get broken, and so on. And then you need to interpret this dialogue and find out, first of all, is it justified? Is this a real loss? And is it covered by the insurance policy? And isn't it a fraud? Yeah. So this can be done with AI. We have this example. So this would be an ideal case, for example, for GenLayer. Yeah. So to have some information gathered from the customer, and then interpret this complex data and deliver a result, yes or no, or how much is the payout. And so this cannot be done by just a database lookup, but we need much more complex interpretation with an AI model.
Makes sense. Albert, do you want to chime in on this and share some information on, or your thoughts on how we can automate this, and like the use case examples you like the most, or like?
Yeah, no, there's a lot of points there, I think. So what I see here is, right, you found the data source that makes sense for this specific type of insurance, right? I'm sure that's quite complex. Like, you need to make sure that it's reliable, that it's constant, that it doesn't. That's good, right? And then, like, you basically have built a protocol on top of that, right? Like, of course, if you had the possibility to have any type of data come into the contracts, then you would be able to create many more types of insurance, right?
Yeah.
That's parametric insurance. Ultimately, what you want is, even if they're like small amounts, let's say these $200, right? You need something that's like streamlined enough that even small insurances are possible. The problem right now is that, like, in protocols where you have human intervention in the middle, right, which is what you have right now in, like, well, some other DeFi protocols, right? As I said before, if you use UMA, for example, it's an example of that, right? Then, well, anything that is like a small amount is difficult to actually work with, because, like, the humans cost more, right? Like, if it's a $20, $100, $200, right? So, like, flight insurance is very specific, and it's like very much productized already. You already have a specific oracle for that, and so on. What GenLayer brings to the table is that now anybody can build an insurance on anything, right? And then what Etherisc can do is, like, create the framework so that people can essentially build an insurance on whatever they want to do. And then I guess the question here for me is, like, okay, so, like, how deep do you want to go with the AI, right? Like, who's doing the actual assessment of, like, what is the price, for example, for an insurance, right? Do you think that can be done by the AI, or only in some situations? Do you think, like, how much hand-holding are you thinking you can do here, or not?
Yeah, I think the pricing of an insurance product is not rocket science. Yeah, so it's actually look at the history. Yeah, you have a certain risk, and you look at the history. In our case, for flight delay, it's only 3 months. In other cases, for crop insurance, we have sometimes even up to 30 years. So it's a very broad bandwidth what you can use as historical data. But then you make an analysis. Yeah? How many losses did you have? What is the average loss? And the average loss divided by the number of cases is the premium. Yeah, because that's the minimum premium. Yeah, so of course on top you will add a margin. On top you will add cost for running the whole infrastructure, the cost for marketing, and so on. But the base price is always the so-called expected loss. Yeah, so history, number of cases, the average loss, and then the sum of the losses divided by the number of cases is the pricing. That's pretty easy. Of course, it can be a problem to get the right data. Yeah, high quality data, reliable data, and that makes it complicated. But I'm also pretty sure that you could train an AI model to extract data from a lot of different sources and create pricing models, because this is a standard process. And we have done this, for example, in Germany. A student made a master thesis on this for train delays. Yeah, so we have a lot of different trains, and the difference to flight delay is trains have always connections. Yeah, so you change your train, and to travel from Munich to Hamburg, you have 3 different trains. So you need to take this into account, and you can also change trains. So it's a bit more complicated, and so he trained an AI model to predict the delay of a certain connection from, for example, Munich to Hamburg, and this was very successful. So it can be done. It cannot, probably it's currently difficult to do it in a completely generic way. So of course, if you have any new risk and you just say, give me a pricing, then probably no model in the world will give you the reliable results. But if you can specify your risk and your product pretty nice and pretty concrete, then an AI model will be able to create a pricing table. And so I think this is also probably one application, because that would remove one layer of black box, which still is in the process. Yeah, if you look at our crop insurance, and you have this actuarial analysis, which is a black box. Yeah, nobody can understand this. We need to trust the actuarial that he did his job correctly. So if you could make this more objective by integrating an AI solution, which is documented and verifiable on blockchain, then that would add another layer of trust to the whole system.
It's very interesting. Have you looked whether the LLMs have a bit of an understanding of the risk of a specific insurance product?
LLMs, in my opinion, have no understanding at all of anything. So that's my personal opinion. I know that there are different opinions. For me, an LLM is still a statistical machine which creates a certain output based on inputs, and this works astonishingly well. But there is no world model behind it. Yeah, so an LLM has no internal model of, for example, like our plant model. Yeah, we have maize in Kenya. Then the maize needs a certain amount of rainfall and wind, and depending on the weather conditions, then you have such and such yield on the field. So I don't believe that an LLM has such an internal model of maize, for example. Yeah, it is trained on a lot of different input, so it can extract the available knowledge from the input, but it cannot create new knowledge, at least at the moment. Yeah,
I understand. I guess the question is more like, like how much documentation is there, on specific insurance products and the risks that they have in a specific situation, and how accurate is the internal knowledge from the LLM already for
I think
specific product?
the available LLMs are very generic and very how you say, broad. So they are not trained on a specific outcome, but they are specifically created to serve a lot of different purposes. So you can actually ask them any question and you get a more or less good answer. So for our purposes, we probably need specifically trained models. For example, our train delay model was trained on a huge data set of different train connections, which is also not available for free on the internet. So probably no LLM has this data for training. So of course, the quality of the outcome will also depend on the quality of input of the training data. So for many insurance perils, you will need specific training data. And the better the training data, the better the outcome. That's also
got it. So then it's like, for example, you guys could be providing this API so that from the intelligent contract, it's connected to the API to understand what's the pricing for that specific product, right? And then it can be the user that's basically defining the insurance for that product, or it like taking what's the risk, what are the data sources that should be considered as well. Of course, I think that the data source is very important, right? So like getting a bunch of them and trying to find like how to like balance the different inputs that it's generating, right? But essentially, the combination of both, it means that you have a way for anybody to create an insurance on essentially anything, as long as you have already with the risk parameters, the data sources that should be accounted in the mix, right? And that's it. Very powerful.
And I think we are still very early in the development. So ChatGPT has been released 2 years ago, so it's very, very early. So I expect that in a few years we will have a huge number of specialized LLMs for different purposes, and probably also for statistical analysis like insurance or finance. And so I think we just need to wait a bit, and then we will have access to models which can do things which we cannot even imagine today. So I think it's still the beginning of the story, and not the end.
To me, it's insane, because like if you think about it, Sam Altman has this says like he's like, these AIs are going to be 100 times more powerful. If what you're building is not going to be 100 times more powerful when they are, then just don't do that, right? It's like not worth doing the starter, right? And what I'm fascinated about GenLayer is that it will be better as AI will become better, right? Like there's going to be ever more type of features that are possible. Like maybe right now they're not good at that, but in the future they can be good at that, right? And it's going to be, like the type of applications to be built on top of it. They're just like ever increasing. So cool.
Albert, I think what will also be interesting for our viewers, maybe, I know it's a tough ask. Maybe you can sum up like in a minute or two why, as Christoph mentioned before, like reliable data sources. Why is this reliable not always given? Like especially if you think of someone using GenLayer, how are we making this data reliable?
So the problem is that the internet is not what's called the deterministic, right? Like deterministic means that for a single input, you get, for a specific input, you get specific output. And if you repeat, you will get the same output, right? The problem is that everybody here knows that you can go to a website and you get a different result. The web has crashed, the content has changed, the cookie is different, whatever it is, right? And the problem is that right now, like if you're going to a let's say, the weather condition, for example, like if you're going to a website that gives you the weather right now in Dubai, say, if it's giving you the wrong weather from time to time, that doesn't really work if you're trying to make a decentralized insurance protocol, right? What you can do then is you can essentially aggregate the outputs of different websites and evaluate, is this response good enough? Like say, for example, you go to 5 and you say, 4 of the 5 need to be saying the same, or just, get 5 more, let's say. Yes. So this can be done at the application level to essentially remove the reliability on a single source of information, right? But this also can be done at the consensus level on our end, which is that the validators, multiple validators, are going to go and essentially express their opinion on what's actually happened. It's not going to be like there's a single entity, a single validator that goes and fetches some result. It's going to be a bunch of them that will go fetch that result and then come up with a response, right? It's based what Edgar said before, the jury theorem, which is like the wisdom of the crowd. Right? It's like, okay, instead of having a single judge that makes a decision, these judges are biased, these judges are wrong. If you get a bunch of them that give you an output, right, and they consensuate the output, it just becomes more correct, right? We've got a representation, like an animation where you can just like see, with a single validator 5 or 11 and so on. It's very, very notable how the difference is. Like it's, nobody wants to be using an AMM or an insurance protocol that works 99% of the time, right? For DeFi, you want 100%, and you will not be able to get 100% if you're relying and trusting a single model, because using a single model, it's essentially having a trusted model, right? You're trusting that model, right? So yeah, that's the approach. I think it's both on the application level, right? So like Etherisc should go and fetch from multiple data sources and then aggregate those, right, in a way that it's reliable enough. That's on the code side of things, right? But it can be made so that, as long as you have sufficient data sources, you're not really trusting on one of them, right? And that really opens up. So for example, when we're talking before about like the assessment of the risk, right? It's like, so who's providing this assessment, right? Is it only Etherisc? Is it like, can you aggregate multiple of them so that you get, whatever, the average between them, for example, right? There's a bunch of different things that can be done to truly decentralize this type of application, right? So like, how do you really create a permissionless, completely trustless, decentralized insurance marketplace, right? That's what Etherisc can do, working with GenLayer.
Exactly.
Amazing. Thank you, Albert. Okay, guys, we aware of the time. We have like 10-15 minutes more. Essentially, we'll also have, let's see, so far no questions in the chat. Maybe we'll have some towards the end. Edgars, can you say something more about the technical implementation? Like, whoever wants to integrate the intelligent Oracle, like how much time does it take? How can you integrate that? How does it work for any business that wants to connect, any developer that wants to use the intelligent Oracle? Can you tell us something about that?
Yeah, let me, I will share my screen again, show it in action, actually, because we just launched this product called the Intelligent Oracle. And it's fully open source under the MIT license, so completely free to use for anybody to integrate that. Right now, on our current, let's say, local network, we call that, which means we have this consensus mechanism. We have the different validators working together. It's just run by a single entity, which will then get progressively decentralized through testnet, through mainnet. But you can already kind of see it in action. I want to show you kind of how this actually works out for a very simple flooding use case. So the real superpower of GenLayer is, or at least one of them, is that you can ingest raw websites. So you don't need necessarily an API. You can have a fully natural language website. So in this case, it's a UK government website about flood warnings in the areas of Wessex. I just picked one where there's some flooding going on to kind of showcase how it works. But you can see it's just a raw website. There's no API, there's no processed data. It's like a normal website that a human would look at. And then we have this live already. So this is, as I said, is running on our local network, but it's the full intelligent contract as well as this Explorer front end, where you can create different oracles on all kinds of different topics. You can see, people have created oracles on football matches or like the top songs in a Billboard top 100 or elections or all different kind of things. And here I created a couple for these flood warnings. So here we have one that's already resolved. This was looking at this query more area. And then we have one that's still in progress, and I'll show you how this gets resolved. So if we click into it, you can see this is the full definition of the oracle. It has a title, it has a description. Basically, we're going to try and see if there's any flooding, more specifically, if there's a flood warning issued by the UK government before December 31st of 24. Potential outcomes are either it happens or not. So basically, imagine, this is your insurance protocol that is going to pay out if there is a flood warning happening. There's some rules, and then we have this place where we define what are the acceptable data sources. In this case, is one specific website, the one that I showed you, this riverlevels.uk.
I think it's important, Edgar, to also say
yes.
the developer of the dApp could choose which data source to choose, right? That's exactly what we've been talking about before. You
Even
could
more
use
than
the
that,
Oracle.
in this case, it's not just the developer of the dApp, it's the creator. So in this case, the end user. We make it very easy. There's an agent that actually helps any end user to create a well-defined Oracle. And depending on the application, you might want to let your users do that or the developers do that. But really, yeah, it's on demand. So it's not. I didn't have to pay anybody $1 million to set up a full Oracle solution for just this question or anything. I just told, hey, I want to do this insurance on flood warnings based on this type of data source. And let's try it. Let's actually get a resolution. So, let me just pull up that specific one. So, we're looking at here, you can basically see this is the data source. So I've set up that this website is the only valid resolution source, and here we clicked into the specific place that we're looking at, this middle haven. And what I can do is basically I take this URL and I submit it as evidence. And there's different ways to do it. In this case, we submit the evidence. You can imagine this is the user or some automated process, whatever. And we submit this for resolution. And basically now it's going to go through the whole consensus process that I outlined. So there's a leader that proposes a result, and then these other validators vote on the result. And hopefully we'll see how this kind of plays out. It takes a little bit of time, because you have these large language models. So while it's working, this is more for the technical people, but I imagine there's some in the audience. It's nothing crazy. So this is actual Python code. Many people have at least played around with Python. So this is going to look more or less familiar to you. And this is the Oracle. So this is a contract that actually goes directly on the GenLayer blockchain. So it's fully decentralized. And after it's all kind of set up, we can look at the resolution method. And the interesting part starts here. Basically, we're saying, hey, contract, just go straight up to go to this web page that we provided as the resource URL, and then ask your large language model, whichever it is for each validator. Here, given these inputs, basically given the web page data and given all these rules for the resolution of the Oracle, analyze all the inputs, give you a reasoning, and then determine the outcome. And you do this for each source. There can be multiple sources. But basically, the LLMs analyze the sources, whatever web data they ingested. So it's super flexible. It's not relying on any sort of API or kind of specific structure of the page. It could change completely. You can have quite broad, acceptance of different sources. Extract, what is the resolution for this specific outcome. And then a second stage where you then take all the outcomes of the different sources and combine into single outcome. So let's say you defined what Albert was saying. You don't want to trust just a single source. You would say, go to these three different sources. And if at least two of them say there's a specific outcome, then you trust that. So you can define these kind of rules in natural language. So again, very flexible. These rules can be quite advanced and complex, not just very kind of low-level programmatic, and you just describe them in natural language. And this runs on the blockchain. And look, we can switch back to the Oracle, and it's resolved. So basically ingested the web page and determined that the outcome is that the flood warning was issued, which is correct. You saw that on the web page. There was a flood warning for this region. It was issued, so it's been accepted, it's been resolved, and this could very much automatically trigger a payout or go to the second stage for human verification, just in case, or have some process for kind of resolution by humans in case somebody doesn't like the outcome, or it can fully automatically trigger the payout, and this would happen, within hours, not days or months or whatever you have it. So in terms of actually kind of projects integrating this, so this is fully open source, fully live on GitHub. You can go to intelligentoracle.com and it's going to have all the links. And for now, you can run it on your local network. You can talk to us. We can help you kind of integrate it. You can modify it to suit your needs in any way you want, and start this integration process. And then in the future, once it's all on mainnet, it's going to be as simple as calling out, kind of building some integration with a smart contract on your native blockchain. And that's going to take care of all the inter-blockchain communication, resolution. All of this is going to be linked up, and then you can integrate it into your product.
It's going to be a very big difference, because if you think about it right now, the cost of resolving like a NUMA dispute, let's say, that's like $5,000, something like that, right? So it can be hundreds, thousands of dollars. well, here it's going to be, $1, $2, something like that, depends on how many appeals and so on. But it's essentially just the gas, right? And with that, you get, a bunch of AIs. It's really very different, like how many AIs are actually evaluating the response, right? I mean, maybe we could show that the jury theorem side of things, right? But you can there's a very big difference in like how many participants there are. That obviously has an impact on the price, but again, it's just the gas of paying the validators to participate in the consensus, right? So really makes it easy for everybody to build new things on top.
I'll try and find the link, but here already you can see that there were 4 other validators that kind of voted on this outcome. So one of them was selected to propose the outcome, and then 4 other ones checked. Also, in this case, also went online, fetched the same data, did the same extraction, made their own decision, and voted if they agree with the leader or not. And this can be escalated to even many more validators.
Yeah, I think that's amazing. Edgar's, what you just showed, because I'm aware of time. We have like 5 minutes left. We just mentioned faster claims processing, lower operational costs, like lower by a few X compared to other solutions that we have, enhanced transparency.
Or there's a magnitude even, so.
Yeah, correct. So maybe a question for Edgars and Albert, and then for Christoph to kind of wrap it off. What is Edgars and Albert? What are you guys, with those features that the Intelligent Oracle has, looking forward to the most, that the dApps built on that? And Christoph, what do you think? Which kind of insurances would fit on Etherisc with the Intelligent Oracle? What are you looking forward to the most? Whoever wants to start.
To me, the game changer with GenLayer is you basically have a decision-making protocol, right? Like you have a protocol that can make its own decisions, right? So that not needing humans means that, for example, you can have a DAO that is capable of evaluating proposals and making decisions and spending money on whatever it thinks that it's correct in a way that it's essentially like, unstoppable, truly unstoppable, right? So we have quite a few examples of people working on that. And I think what we'll see is just like completely new types of primitives that until now were just impossible to implement, and now are going to be possible. And the way I look at it, like, I like to think that what we saw in the DeFi summer, when, like every week there was a new protocol that could do something absolutely magic, right? I want to think that it's going to happen again because of GenLayer, right? On top of GenLayer. And like, so yeah, I'm really looking forward to that.
Edgars, whoever wants.
Yeah.
Go ahead.
I think the example with the flood oracle is already setting the stage, so to say. Yeah. So anything where you have distributed data which can be collected, which can be, and of course, all these data sources which are not available already with an API or with a structured data, which are presented on web pages in natural language, in descriptions like what we have seen. So these are all valuable data for risk assessment, for insurance use cases. And this is a huge area. And I'm just starting to make up my mind, so what could be done. I think there are lots of different applications where we could turn this unstructured data by using of AI oracles into the structured data, what we need to make decisions on for insurance claims, for example. And so I think there are nearly unlimited applications. And so from my ideal would be that we would create something like a no-code environment where people can just define the rules, what we have seen in your code example. Yeah. So actually, this could also be put into a text box in a user interface. Yeah. So the user just says, okay, I want to create an insurance product. This is my target group. This is the oracle which will decide on the claims. I have the pricing, and even the pricing could be outsourced to the market by creating something similar like the prediction market approach. Yeah. So, for example, in the traditional insurance area, there are also a lot of different risks which cannot be calculated based on historical data. For example, SpaceX launches. Yeah. So obviously there is no history. So, but you can insure this because you have some idea how probable a fault is or a loss is, and then you just make a pricing based on rule of thumb. And then as you sell policies and you collect claim data, then you adjust your pricing. So you just start because it's much better to have something which you can offer to your customer, even if you don't have the perfect pricing. Yeah? So you start with a rule of thumb pricing, and then you improve your pricing as you sell your stuff. And this could also be done. So you do not need a long actuarial analysis, but just something like a market. People make a good guess. They start selling a product. Then we collect claims data and adjust pricing as we go. So this could be done in a way that you don't even need to code a single line of Solidity. Yeah. And I think these type of applications, these are the future, and because they enable a much broader range of people to create products and use their creativity.
Yeah. Okay, I've just been notified that the live stream stopped exactly 35 seconds ago because it was scheduled for an hour. So everyone, thank you very much. Edgars, Albert, Christoph, thank you very much. I'm just going to say it for the record, visit intelligentoracle.com. As you can find all information there. It's been pinned during the live stream, and we've reminded people multiple times to look it up there. We've also shared the Etherisc link and the blog post to the Intelligent Oracle. Yeah, Christoph, thank you for joining us for our first live stream.
Thank you for having me.
It was also kind of a first for us. So thanks for enduring all the pain of communicating with me in the Telegram channel until I figured it out. It was
great.
It was the rabbit hole, I'm gonna tell you. So I'm happy that everything worked well. We had an average. We had 310 views altogether, and 140 were watching on average. So I think that's solid. We had no spam comments in there, so I think that was more or less real users.
Okay, great. Tremendous.
Thank you, Christoph, and thank you, Tony, for putting it all together.
Very glad
guys,
to see that.
Thank you very much.
Yeah, very glad to see the crypto, like that you see the value of having this type of protocol. Right? Really looking forward to see what you guys can build on top, and like always, ready to help. So
okay, perfect. Let's go.
Awesome. Let's go.
Okay, thank you so much.
Okay, thank you guys.
Thank you. Bye bye.
Bye bye. See you.